So our lesson is about finding the domain of a function. So make sure you've got out paper, pencils, sticky notes, highlighters, pen, pencil, whatever it is that you want to do to write down these notes. I'm going to do a problem and then ask you to stop the video and then you do a problem. So your assignment is going to mean that, like, here's our first one. You're going to follow along and have these notes in either write them on this paper or write them on some notebook paper, but you're going to submit all of these problems, but I'm going to do half of them and you'll have to do the other half on your own or using the GroupMe or using tutoring. But let's go ahead and start here where it says find the domain of the function. Find the domain, which everything x can be. And then they want us, we're going to put our answer in interval notation. So a quick mini lecture. If a problem looks like this first one we're going to work on, not like this one, which has a square root, and not like this one, which has a denominator, I won't say every time, but if it does not have a square root and it does not have a denominator, you are very likely safe to say it's going to be all real numbers. You can put like a double bar R. You can say X is an element of the real numbers to get us going. So ultimately we have to use interval, which is going to be from negative infinity to positive infinity. So tips and tricks, one being that if it's not a square root, if it's not a denominator, then it probably very likely is going to have no limitations on what the X can be. But a way to think about that, check it, go back around during a test and do what I call cheaters, because these are legal cheaters. Do the test one way, like we just looked at this and said there are no denominators and there are no square roots. I'm going to declare it's all real numbers. But then when you go back around, maybe do something different. Like in this one, the slope is 2. The y-intercept is 7. So a real quick sketch of here's 7, and then we're going to do the slope is up 2 to the right 1, up 2 to the right 1. So if we go up 2 to the right 1, up 2 to the right 1, we can also do the negatives of this, down 2, down, or to the left 1. So from here, I'm not sure what that dot is. Hang on. I'm not sure what just happened, because if I'm here, I'll go ahead and say this is 7. We'll go up 2 to the right 1, up 2 to the right 1. We can also go down 2 to the left 1, but either way you go, it's not a very straight looking line there, but this is linear. It is a line. And with it being a line, let me change colors real fast. There is going to be no place that we can't go to the far left of the X's and no place that we can't go to the far right on the X's. And so it's going to hold true by our talking about the square root and this denominator, an X in the denominator and X in the square root. Since none of that's present here, we can very likely, very confidently say that the finding, the domain of this function is going to be all real numbers. It's going to be negative infinity to positive infinity. So now what I would like you to do, and let's see if this will let me scroll and go up and leave my writing there. Oh, it does. So now what I want you to do is to go do this problem. And you need to pause. You need to go do this problem. And so let me go ahead and number. That's going to be a little bit confusing if I just keep using number 1, me, number 1, y'all. So let me do across this way. So 1, 2, 3, 4, 5, 6. This is how we're going to number them. And if you're writing on notebook paper, just follow these sets of numbers. 7, 8, 9 is the one I want you to do by yourself right now. 10, 11, 12, almost done. 13 and 14. So right now you're pausing and you're going to do 9 by yourself. When you get done with 9, turn the video back on, and I need you to join me at the top of this page. So you're responsible for turning in all the work, even everything I just showed you on question number 1. And then now you're responsible for turning in the problem number 9 also. So you might want to wait on that, or you might want to go ahead and do that one right now. But then I would like you to join me at question number 3, or problem number 3. Problem number 3 has a square root. And so this isn't a real quick, oh, well, it's all real numbers. We have to do something about that. So let me get a different color. And because it has a square root, we're going to have one of two things that we can do, either with a square root or if I have an x in the denominator. And so I'm going to go up here and do some mini notes. If I have a square root and I have an x underneath that square root, I've got to remember that everything under the square root has to be bigger than 0. So all of my junk under there has to be greater than or equal to 0. All of that stuff underneath the square root has to be greater than or equal to 0. I can set all of that junk equal to or greater than or equal to 0, solve for x, and bam, I've got my answer. The other thing I keep talking about is we really don't care what's in the numerator. That's a whole other set of stuff that we do. But when we're trying to find domain, if there's something in the denominator, then we need to pull that out and put all of that something and say, all of that something cannot equal 0. Then we can solve for x, and bam, again, we've got what we're looking for. So the one that I want us to look at right now, it is a square root. It has an x or a variable in the square root. So we're going to pull out all the junk from underneath the square root and say it's got to be greater than or equal to 0. So it's a real quick tip, a real quick thing that you can do. And here we are at number 3. I'm going to take all of the junk underneath the square root symbol, sign, and say the 3x minus 5 all has to end up being positive for this to work. And we're in the real number system. I can't have it being imaginary just yet. And so a real quick solve that 3x is greater than or equal to 5, divide by 3, divide by 3. Then the x is greater than or equal to 5/3. We are done, except the directions say put this in interval notation. So I like to be able to see everything that I'm doing. And so 5/3 is about 1 2/3. So being really, really lazy, here's a 1 and a 2, and our 5/3 is about right here. So there's my 5/3, and all of my x's have to be greater than or equal to. There's my equal to. They got to be greater than. And now that I've got the graph, I can go right to my interval, which is going to be bracket 5/3 all the way to infinity, parentheses, done. And so now I'd like for you to stop the recording and for you to go do problem number 2. So this is one that I'm asking you to do, and you can probably tell it's got a square root, so I'm up to something there. And I've asked you to do 9 down there. So you're starting and stopping this video, and this is a great set of problems to take to tutoring and a great set of problems to talk to each other in the group me. So now I want you to join me over here. I believe it's number 8 where we're headed. So I want you to join me here at number 8. And if we're looking for domain, I don't care what's in the numerator. The denominator is what's going to cause issue. And so if it's a denominator, I'm going to take everything that's in the denominator and say that cannot be 0. If it's 0, game's over. So it cannot be 0. A quick solve, I get a 5x cannot be negative 10. Divide by my 5, divide by my 5, and my x cannot be negative 2. Again, I do really well when I see things. I have to make my eyes behave. So if it cannot be negative 2, that means everything coming up to negative 2 is good, but parentheses don't include it. Kind of jump over it and then start at parentheses and head on out to infinity. So we have to write it in interval notation. So negative infinity up to negative 2 parentheses, unite it with negative 2 and head out to infinity and beyond. And we're done with that one. So the one I'd like you now to do is right over here, this one. As you can hopefully tell, I'm bouncing around to be able to give you consistency. Boy, that doesn't sound right, bouncing around for consistency. So we just did one that had a denominator. Now I'm asking you to pause the video and you do that one that has a denominator. Once you get back, we're going to do this one. So if you're already back, I'm going to go ahead and change color to help my eyeballs out here on this one. And let me go ahead and pause myself on the recording. Give me a second.